Now let's take a look at how much energy is actually stored in a spring or the rubber band, of course, that you had last week that we stretched. So looking at our graph right here, we graphed the force and the length of the spring, and we got a line that looked like this. And at some point, I asked you to find the area under the graph. And I also asked you a question, which was, how can you tell how much energy there is in the rubber band? And a lot of you said that, well, you can tell how much energy there is by how much stretch it actually has. So you were essentially saying that X has something to do with it, displacement has something to do with it. The more it's stretched, the more energy we've stored into it. All right. But you also know that when you stretch it, it gets harder and harder to stretch as you go along. That's the more force you're putting into it. As it gets longer, there's more force. And so some of you said, well, the energy is force times the length, right? Not force divided by the length, that's the slope, but it's force times the length. And if we take force times the length, it's not too hard to think that that might be the area under the graph. To get area, we take base times height. So that would be length times force. Length is on the x-axis, force is on the y-axis. And so if we get the area of this, that kind of gives us the idea that it might be energy that we're talking about. But let's look at these springs over here. Now, this is just going to be the opposite of the rubber band. With the rubber band, we were pulling it downwards. But I have a spring here, it's attached to the floor, and I'm going to pull it upwards. Now, at the very start, the spring looks like this. I actually have 4 stretches of the spring. This is 4 different diagrams of the same spring. And when the spring is right here, it's not very long, and you guys know that it would not be very hard to stretch that spring. It's hardly stretched at all. So there'd be hardly any energy, according to what you've said, hardly be any energy stored in that spring. And it's kind of easy to imagine that we'd be talking about the spring like right here. It would fit under that graph right there. All right, so if we were to take the area of that graph right here, that might be the energy stored in that spring. And then if we stretch the spring out, you know that we're storing more energy in that spring. And now that spring is, as high as this part of the graph. So it's not too hard to imagine that the energy in that spring now is the energy that was in it before, right here in this graph, but also the energy that we added to make it this long. All right, so that would be the total area under that graph again. And what about if we stretched it to this far? Well, if we stretched it to this far, it would be that tall. It would be as tall as the graph here. So it's kind of easy to imagine that we'd be talking about the energy right there stored in that spring. But also we had to stretch it to here, and we had to stretch it to here to make sure that it was all stretched that far, right? So we had to stretch it to here, and then here, and then here, or here, and here, and here. So it's not too hard to imagine that the total amount of energy, again, would be the energy in that entire graph. Okay, and then one more time, if we stretch it one more time, well, now it's going to be this tall, all right? And so it'd be the little bit of energy plus the more energy plus the more energy plus the more energy. And in fact, the energy in this spring right here has to be all the little bits of energy that we added into that spring to get it to be all the way that high. All right. And so to get the energy of a spring, we would take the area of this. So we would take the base times the height divided by 2 because it's a triangle. All right. If I only want to know the energy of the little spring, then I would take the base only to here and the height only to there. And that would give me the energy in that little spring. All right. Now, if you think about it, the units on that, the units on force were newtons. And then the units on the length or the displacement of the spring were meters. So try and do a scribble here, meters. And that, in fact, is our energy unit, newtons times meters. It has another name. It's called joules. We're going to talk about that a little bit more. Newtons times meters is our unit.